The People's Liberation Army Navy has executed one of the most dramatic naval transformations in modern history. In less than 7 decades, it has moved from a coastal defense force operating rusting Soviet hand-me-downs to a global blue water navy that now challenges American undersea dominance. At the heart of this metamorphosis lies a relentless, often secretive pursuit of nuclear-powered submarine technology. The story is not simply about building better boats. It is about systemic reconstruction, industrial autonomy, and a doctrinal shift from platform imitation to network-centric warfare. By April 2026, China's nuclear submarine fleet has reached a historic inflection point, launching more nuclear tonnage than the United States over the previous 5 years, and forcing a fundamental recalibration of maritime power in the Indo Pacific. The origins of China's submarine ambitions trace back to the Cold War, when the Soviet Union provided the foundational industrial architecture. Under the 1950 Sino-Soviet Friendship Treaty and subsequent agreements in 1953 and 1959, Moscow transferred complete submarines and technical documents for the Whiskey, Romeo, and Gulf classes. These diesel-electric boats were not merely weapons, they were classrooms that taught China how to weld pressure hulls, fabricate propulsion systems, and train the first generation of submariners. When the Sino-Soviet split abruptly severed this mentorship in the early 1960s, China was left with the hardware to build, but no longer the software to innovate. The forced march towards self-reliance exposed gaping deficiencies in metallurgy, precision machining, and nuclear science, setting the stage for a painful but essential learning curve. Chairman Mao's authorization of the 09 project in 1958 marked China's entry into the exclusive club of nuclear submarine aspirants. The resulting Type 091 Han class was Asia's first indigenously built nuclear attack submarine, a proof of concept that proved more significant for its existence than its combat effectiveness. Western assessments described the Han as excruciatingly noisy, its acoustic signature comparable to late 1950s Soviet boats, with inadequate radiation shielding that dangerously exposed its crews. Its reactor, while functional, was a rudimentary loop design that lacked the reliability and quieting characteristics of contemporary Western plants. Yet, for all its flaws, the Han class taught China the brutal realities of integrating a nuclear power plant into a submerged hull, lessons that no amount of theoretical study could replace. The most important leap in Chinese submarine capability came not from a domestic design, but from a calculated purchase of Russian Kilo-class boats in the 1990s. China acquired these famously quiet diesel-electric submarines specifically to deconstruct the engineering philosophy behind their stealth. Chinese engineers did not simply copy the anechoic tiles, they internalized the hydrodynamic philosophy, the machinery rafting techniques, and the propeller skewing principles that made the Kilo one of the world's quietest submarines. This absorption of methodology, not mere technology, directly informed the next generation of indigenous nuclear boats. The Kilo acquisition served as a bridge, transforming Chinese industrial base from one that could copy a hull to one that understood how noise propagates through metal and water. The Type 093 Shang class, first commissioned in 2006, embodied the lessons extracted from the Kilo program and Russia's Rubin Central Design Bureau consultations. Its teardrop hull, improved anechoic coatings, and quieter machinery foundations dramatically reduced its acoustic signature compared to the Han. Subsequent variants evolved rapidly. The Type 093A integrated a towed array sonar and a reshaped sail reminiscent of Western designs, while the Type 093B added vertical launch tubes for anti-ship and land attack cruise missiles. By 2026, at least 9 Shang-class hulls are operational, forming a credible regional attack submarine force that can threaten carrier strike groups and project power ashore. For the first time, Chinese SSNs could operate with enough discretion to complicate an adversary's planning. Parallel to the attack submarine program, China fielded the Type 094 Jin-class ballistic missile submarine, the platform that finally delivered a sea-based nuclear deterrent. Initially armed with the JL-2 missile, the Jin-class could reach targets across Asia and parts of the Pacific, but required perilous sorties east of the First Island chain to threaten the American homeland. The integration of the longer-range JL-3 missile changed everything, enabling launches from the relative safety of the South China Sea bastion. With at least 6 boats by 2026, China could maintain continuous at-sea deterrence patrols, a foundational requirement for a credible second strike capability that no longer exists purely on paper. Despite undeniable progress, Western intelligence assessments consistently indicate that Chinese submarines remain louder than their American and Russian counterparts. The Type 094 is frequently compared to late 1970s Soviet SSBNs in terms of acoustic detectability, a weakness that Beijing has sought to mitigate through geography rather than engineering. By nesting its strategic boats inside heavily defended bastions protected by layered anti-access systems, China compensates for acoustic inferiority with sheer defensive depth. However, every decibel reduction achieved between the Type 093 and the emerging Type 095 narrows the detection envelope that U.S. anti-submarine warfare forces can exploit, slowly eroding the sensor advantage that has underwritten Western undersea supremacy for generations. The launch of the first Type 095 Sui-class from Huludao's Bohai shipyard in February 2026 signals China's intention to compete at the very frontier of submarine stealth. Satellite imagery reveals a boat displacing roughly 10,000 tons submerged, with an X-form rudder configuration and a pumped jet propulsor that drastically reduces cavitation noise. Analysts from the U.S. Naval War College assessed that the Sui-class could approach the acoustic quieting of a Russian improved Akula, a truly worrisome benchmark. If those estimates are correct, the Type 095 represents not a copy of Western designs, but an indigenous platform that closes the acoustic gap to a point where detection becomes probabilistic rather than certain, the very definition of operational risk. Still under construction, the Type 096 Tang class aims to correct the acoustic vulnerabilities that have dogged the Jin class from the start. Expected to displace around 20,000 tons and carry up to 24 next-generation JL-3 or JL-4 missiles, the Tang class is designed from the keel up for silent, survivable patrols far from home waters. Analysts note evidence of double-hull construction, internal rafted machinery mounts, and possibly an ice-rated hull for future Arctic operations. If the Tang class achieves its design parameters, China will finally possess a boomer whose acoustic signature does not force it to cower within a bastion, fundamentally altering the geometry of nuclear deterrence in the Pacific. The most visually striking indicator of China's submarine ambitions is the physical expansion of the Bohai shipbuilding heavy industry complex at Huludao. Between 2019 and 2022, the facility added a massive new construction hall and assembly bays, enabling the simultaneous fabrication of multiple nuclear hulls. The output data is staggering. Between 2021 and 2025, China launched 10 nuclear submarines totaling 79,000 tons, comfortably exceeding the 7 hulls and 55,000 tons launched by the United States over the same period. This 1+2 production tempo, 1 ballistic missile boat and 2 attack or guided missile boats per year, is a rate the U.S. Navy set as a target for 2028, but that China is already achieving today. A nuclear submarine is only as effective as its ability to stay at sea, which is why China's network of overseas logistics facilities is as important as the submarines themselves. The Djibouti base, opened in 2017, has matured into a heavily defended hub with deep water piers and underground storage, capable of supporting extended Indian Ocean patrols. Cambodia's Ream Naval Base offers a dry dock and persistent docking in the Gulf of Thailand, positioning Chinese boats astride the critical Malacca Strait choke point. When combined with the Yulin underground submarine pens on Hainan Island and potential access to Gwadar in Pakistan, this network transforms the PLN from a home water fleet into a globally persistent force that can rotate boats through distant operating areas without long transits. China has complemented its submarine buildup with a sensor architecture that seeks to render adjacent waters transparent to adversary submarines. Dubbed the Blue Ocean Information Network or Underwater Great Wall, this system integrates a 5-layer grid from seabed hydrophone arrays to satellite-based radar altimetry. Autonomous underwater vehicles, gliders, and AI-driven fusion centers create a predictive kill web that aims to reduce enemy submarine survivability in the South China Sea to single-digit percentages. The network is most mature between Hainan and the Paracel Islands, but is projected to expand along the entire maritime Silk Road, effectively weaponizing oceanography against any submarine that enters Beijing's claimed waters. The evolution of China's submarine force cannot be understood without examining the doctrinal revolution that accompanied it. The 2015 Strategic Guideline of Near Seas Defense and Far Seas Protection formalized a shift from coastal denial to regional and eventually global power projection. Submarines are no longer viewed as solitary hunters, but as nodes in a distributed, survivable kill chain that integrates space-based sensors, airborne early warning aircraft, and surface combatants like the Type 055 destroyer. This system-centric approach means that individual platform weaknesses are compensated by network strength, allowing a moderately quiet submarine to be cued by an overhead satellite constellation and fire hypersonic missiles from a position of relative safety. For all its industrial achievements, China faces a significant deficit in operational experience compared to the United States Navy, which has operated nuclear submarines continuously for over 7 decades. Long-duration deterrent patrols, deep ocean anti-submarine warfare, and complex battle group integration are skills that cannot be fabricated quickly. The PLN has invested heavily in realistic simulators, intensified training cycles, and cadet exchanges, but observers note that the density of Chinese submarine patrols is increasing alongside proficiency. The U.S. Navy, meanwhile, confronts its own human crisis, a shortage of roughly 23,000 sailors, and a severe maintenance backlog that reduces deployable hull counts, narrowing the experiential advantage from the other side. A balanced assessment in 2026 reveals a Chinese submarine force that is numerically large, industrially dynamic, and qualitatively rapidly improving, yet still trailing the U.S. Navy in several critical dimensions. American Virginia and Seawolf-class boats retain an edge in acoustic quieting, sensor fusion, and crew proficiency, while the Columbia-class program promises to sustain the undersea leg of the U.S. nuclear triad. However, China's production tempo, shrinking acoustic gap, and integration with anti-access systems have eroded the conditions under which U.S. submarines can operate with impunity. The balance is no longer one of absolute dominance, but of managed risk, where the costs of a submarine-on-submarine engagement have considerably risen. The central strategic thesis for China's submarine evolution is not that it has matched Western technology in every parameter, but that it has become sufficiently survivable to impose unacceptable uncertainty on any adversary. A Chinese submarine that is only quiet enough can still threaten a carrier strike group if its position is unknown and its weapons are capable. The Type 095, operating in the cluttered acoustic environment of the South China Sea and supported by the Undersea Great Wall, does not need to be invisible, it needs to be unpredictable. That threshold of unpredictability has now been crossed, and it is this shift, more than any single technical breakthrough, that redefines the undersea balance of power in the Western Pacific. Looking ahead, the trajectory of China's nuclear submarine force will be defined by consolidation, not revolution. The Type 095 and Type 096 will enter serial production, gradually replacing older hulls and expanding the fleet toward an estimated 80 submarines by 2035, more than half of them nuclear-powered. Acoustic signatures will continue to improve as integrated reactor designs, turboelectric drives, and advanced hull coatings mature, while hypersonic anti-ship missiles will complicate defensive planning for any surface force. The United States and its allies are responding with increased submarine production under AUKUS and distributed sensor networks. But the era in which the Pacific Ocean was an uncontested American lake beneath the surface is ending. China's nuclear saga story is ultimately a story of patience, investment, and the long view of strategic competition. What began as a desperate attempt to build a reactor with toy model references and wooden mock-ups has evolved into an industrial and doctrinal apparatus capable of sustaining a global undersea presence. The question for the next decade is no longer whether Chinese submarines can match their Western counterparts in a quietness competition, but whether they have already become quiet enough to change the calculus of any planner contemplating hostilities within China's expanding maritime perimeter. The dragon beneath the waves has not yet eclipsed the established powers, but it has emerged from the depths, and it is no longer content to hide.